Hello, good morning. Today, as yesterday, I sent you some documents regarding center of gravity. Already, I have studied in our during classes, and the chapter is completed. But just I want to brush up you that one. That's why I sent that one just to go through it. And next is that, as I told you earlier, I wanted to start this. Dynamics, that portion belongs to you is kinetics. So now, as you know that dynamics is the branch of mechanics deals with the bodies in motion. It is divided into two types. One is kinematics and other is kinetics. So for earlier we have studied only the mechanics related to the statics. So in this unit 5 we are studying this dynamics. Now regarding kinematics is concerned, it deals with the motion of the bodies without referring to the forces causing the motion of bodies. That is, it involves projectiles, linear motion and other things. So that is not there for your syllabus. For your syllabus, the kinetics is there. So kinetics, it deals with the motion of the bodies with referring to the forces causing the motion of bodies. That is, we are referring to the agency which makes it the body to move. So this is called as a kinetics, and this kinetics, we are studying as per the syllabus. One is the D'Alemberts principle, and second is the work energy method, and third is the impulse momentum method. So these are the three things which we are going to cover in this unit 5. As per first of all, we'll concentrate on this one, that D'Alemberts principle. Okay, so this D'Alemberts principle mm, will I'll just 1 minute. I'll set it. Okay. Regarding D'Alemberts principle, uh, so this uh, it based on the Newton's second law. So as you know that the Newton's second law states that the rate of change of momentum is directly proportional to the impressive force, and it takes place in the direction of the force. So here this same Newton's law has been used to apply. D'Alemberts has used this second Newton's second law, and with other concept, with other angle, he has seen this one. So based on this Newton's second law, the force F is equal to mass into acceleration. So that is F is equal to ma. So therefore, instead of the force may be a single force or it may be a system of force, and the resultant of that force we'll consider it as R. So instead of this one, we can rewrite this equation as R is equal to ma, where R is the resultant of the system of forces and ma is the mass into acceleration, where R is the resultant. So D'Alemberts in 1743 put forth this theory regarding motion of particle applicable to motion of bodies also. So in this equation, slightly we can modify this equation, that is R minus ma is equal to 0. So I brought that mass into acceleration on the left side, so therefore the equation becomes R minus ma. Here the term R is the same thing, that is the resultant of the force system, that is the net effect of the any system of force acting on the body, and m into a, that is mass into acceleration. So this is called the inertia force. So entire body, when it is moving under the action of a resultant force, that time it is under dynamic equilibrium. We call it as a dynamic equilibrium. So this dynamic equilibrium, as per the D'Alemberts equation, we can state based on that the equation of equilibrium states that the system of forces acting on a body is in dynamic equilibrium with the inertia force of the body. So the inertia force is opposing the motion of the body, and the external agency or the resultant force system is pushing the body in the forward direction. Under these two forces, the body is under dynamic equilibrium. So this principle we are using to solve many of the uh, problems related to the kinetics. So especially the problems related with the determination of acceleration and other things, this equation is this method of using the D'Alemberts principle is very useful. For example, I can give you an example of lift. Okay, the lift is working, so therefore the lift, when it is moving up or when it is coming down, what are the forces will act on that? When the lift is moving up, that time the the external agency is pulling it up in the upward directions, the weight of the lift is acting in the downward directions, and also the inertia force is also always acting opposite to the direction of the motion. If the lift is moving up, the inertia force will be acting in the downward direction. So there, as we call it as a inertia force, always it will act opposite to the direction of the motion of the body. That you keep it in mind. So therefore, when the lift is moving up, that time net resultant of the force, that is the whatever the force is pulling it up, and also there is some force is acting, weight is acting downwards, net resultant will be acting in the upward direction. That's why the lift is moving up. But in addition to that, it has to overcome the inertia force. So inertia force will be acting in the downward directions. So this will create a dynamic equilibrium of the lift. And second aspect to consider, when the lift is coming down. So when the lift is coming down, though the external agency is leaving that one, so that the force is, it is holding the lift, but though it is going down slowly, and the lift entire weight is acting in the downward direction, and the force from the top by the cable is also acting in the upward direction, but it is slowly leaving it. And as the lift is moving downwards, so if you think of the free body diagram of this lift, that the net resultant of the force acting on the lift is in the downward directions. That's why the lift is moving down. But when the lift is moving down, that time there is an inertia force opposing that, and that will be acting in the upward directions. This is the overall concept of the D'Alemberts principle as far as the statistics is concerned. Now we are going to solve some problems based on this. Just go through it, and also refer the some books on the dynamics, especially there is a chapter in Mahikati also, and go through it, whatever the concepts I have tried to clarify you. And then in the next session I will take up solving of problems based on the DLM principle, with again brief description of this one. Okay, thank you and good luck.